Hello, dear students! This is again your teacher MJ, all the way from the northern tourist destination, Ilocos Norte. Together, let's explore, discover, and understand science. This is DepEd TV. I hope that you are all fine. Are you? That's good to know. May I request you to prepare your modules, your notes, and everything you need for our learning session today. All set? All right, let's do this. Last time, we defined what force is and also discussed the first type of force, which is contact forces. This time, our lesson will focus on non-contact forces. Non-contact forces are forces where objects do not touch or are not in contact with each other. There are two examples of non-contact forces, namely gravitational force and magnetic force. I know this is not the first time you hear about gravity because we have been taught about it since grade school. And today, we'll know more about gravity. Imagine taking a break while touring around Ilocos. Then you decided to eat your hot empanada. Then suddenly, you accidentally dropped it. Oops! Not Pennywise. One of the reasons of that happening is the gravity. Gravitational force is the force that attracts objects towards the Earth. This force is the main reason why we get to enjoy walking, running, and living on Earth. Without gravitational force, obviously, everything will float. Well, that seems interesting, but you won't wish for it to disappear otherwise. Living without gravitational force will be quite more challenging than how interesting you think it is. Drinking water through your glass would be impossible. Many things would be very challenging to do because the moment gravitational force disappears, there will no longer be a force to pull you towards the Earth. To understand it better, let's get back to our example on normal force. We said that the normal force is the force that acts perpendicular to the surface which an object is in contact with. The normal force has an upward pulling effect to the object on the surface. If there is an upward force on an object at rest, there is also a downward force that pulls it downwards, and that is gravitational force. Let's take, for example, 2 kilograms of meat on a plate. The weight of the meat is the gravitational force that pulls it downward. The greater the mass, the greater the gravitational force that pulls it down. Another example of a non-contact force is magnetic force. Magnetic force is the force that is exerted on what we call a field of attraction or repulsion. This force takes place in cases such as between a magnet and a magnetic material. Magnets and magnetic materials have two poles, the North Pole and the South Pole. Attraction of magnetic materials does not take place with the same poles, meaning attraction occurs only between opposite poles. You might be thinking why magnetic force is classified as a non-contact force because the magnets attract objects and eventually make contact with each other. The answer to that is magnets don't necessarily need to be in contact with other magnetic materials to make them move. The force that is being exerted in a field of attraction or repulsion moves a magnetic material without the magnet touching it. Those are the two types of forces and their examples: contact forces and non-contact forces. Last time, we defined force as the push and pull applied to an object. It is the primary cause of all the motions and movements we see every day. We also said that force is present even if an object is not moving. Are you still confused why? That is because we have what we call balanced and unbalanced forces. Let's get to know more about these. Let's start with balanced forces. Balanced forces are those which are of opposite directions and equal in magnitude. To understand it better, we must know magnitude and direction. Magnitude is the amount of force exerted, and the direction is where the force is moving towards. Take a look at this book placed on top of a table. Is it moving? Obviously, it is not. Why is this so? That is because the forces are of the same or equal magnitude. Equal magnitude of forces means there is no change in motion. That is why the book remains at rest. This is what we call balanced forces. Let's also take, for example, an arm wrestling. Let's assume that each person exerts 200 newtons each. Do you think one will win? No one won. This is because the magnitude of forces are equal, meaning neither of the two can make the opponent's arm move. Unbalanced forces are those which are in opposite direction and unequal in magnitude. If one force is greater than the other, and they are exerted in opposite directions, the object will move. Let's take a look at this ball shown earlier. Let's assume that the force from the left is 50 newtons and the force from the right is 200 newtons. Do you think the ball will move? To what direction will it go and why? Great! The ball moved to the left. This is because the force from the right is stronger than the force from the left. Can we calculate forces? Definitely yes. We can combine or add the existing forces that act on an object. The result of this is known as the net force or resultant force. The net or resultant force is the sum of all the forces that act on an object. If the net force is 0, the forces are balanced. This means that there is no change of movement or velocity on the object where the forces are acting upon. Meanwhile, if the net force is greater than 0, that means that there is a greater amount of force, so expect a change in motion and velocity of an object. To solve the net force, we use this formula. We use this as a symbol for net force. Meanwhile, the symbol sigma and the uppercase letter F symbolize the sum of the existing forces in the same line of action. We also use the algebraic signs positive and negative to indicate the direction of the force. Forces exerted to the right get the positive sign, and forces exerted to the left get a negative sign. For vertical forces, forces exerted upwards get a positive sign, and forces exerted downwards get a negative sign. Let's take a look at this example. We have here two teams playing tug of war. Team A exerts 900 newtons and Team B 1,200 newtons. We write it like this. We used Fa as the symbol for the force exerted by Team A and Fb for that of Team B. Since Team A pulls the rope to the left, the force goes to the left, so we give it a negative sign. On the other hand, Team B pulls the rope to the right, and the force goes to the right. we then give it a positive sign. If the sum of the forces is positive, that means that the forces directed to the right is stronger or has a greater magnitude. In the same way, if the sum of the forces is negative, that means that the forces directed to the left has greater magnitude. In solving the net force, it is also important to know the line of action. We can only add forces which are in the same line of action, meaning those that do not belong to the same line of action can't be combined. Now we have learned that in adding forces, we use algebraic signs positive and negative to show the direction of the force. Also, forces can't be added if they are not in the same line of action. Are you having fun so far? That's great! To better understand adding forces, let's try it. A box is at rest on the floor when Michael and James saw it. They decided to push the box from both sides to see who among them is stronger to make it move. Michael, who is on the left, exerts a magnitude of 150 newtons, and James, who is on the right, exerts 200 newtons. What will be the net force? First, let's write the formula. Remember to use the proper symbols. Next, let us write the magnitude of force exerted by Michael and James. Michael has 150 newtons. We give a positive sign to that since the direction of the force is to the right. Let's add James' force at 200 newtons, which gets a negative sign since it is directed to the left. If we add them together, what do we get? That's right! We have negative 50 newtons, which means that the force exerted to the left is stronger. We have here forces which are unbalanced, since the net force is not equal to 0. Let's say we have a bottle of water on top of a table. The normal force is 5 newtons, and the gravitational force pulling it downward is also 5 newtons. What will be the net force? Very good! The net force is equal to 0 since both forces are of the same magnitude. This is really fun, isn't it? Do you want to try another one? Great! Here is another example for you to solve. Take a look at this picture and solve for the net force. What is your answer? If your answer is 40 newtons, then you are correct. You might be quite confused with the two boys pulling from the right side, but the process is still the same. You just need to remember the proper usage of the signs and add them. So the correct answer is 40 newtons. You really did great in our discussion today. That ends our lesson on forces. For us to test what we have learned from yesterday and today's discussion on forces, try to answer the following questions. Write your answers on a sheet of paper and count your scores later on. You will only be given a corresponding time limit for each question. Please be honest with your answers. Try to answer based on what you learned about the lesson. Are you ready? Let's begin. Which of the following is not a unit of force? Dyne, joules, Newton, pound. Joules is not a unit of force. This refers to the amount of force exerted. Magnitude, line of action, velocity, direction. Magnitude is the correct answer. Which of these forces pulls an object towards the Earth? Applied, gravitational, tension, friction. Gravitational is the right answer. What force is always directed opposite to the motion of the object? Applied, gravitational, tension, friction. Friction. That's right. Which of the following refers to the sum of the existing forces in the same line of action? Balanced forces, unbalanced forces, net force, magnetic force. Net force. Good job! If the force is directed to the right, what algebraic sign should be used when adding forces? Positive, negative. Both positive and negative. Positive. Great! If the net force is not equal to 0, then the forces are balanced or unbalanced. Unbalanced is right. If one force is directed to the right with 20 newtons, and another force is directed to the left with 15 newtons, what is the net force? Negative 5 newtons, 5 newtons, 35 newtons, negative 35 newtons. Five newtons. You guys are intelligent. If an upward force is equal to 5 newtons and a downward force is also equal to 5 newtons, what is the net force? 0 newton, 10 newtons, negative 10 newtons, 5 newtons. Zero newton is the right one. Take a look at this picture. What is the net force? 80 newtons, 20 newtons, negative 20 newtons, negative 80 newtons. Negative 20 newtons? That is correct. Did you get a perfect 10? Good job! I hope you all learned from our discussion this week. I am looking forward to another fun, exciting, and more learnings on our next session. This is your teacher MJ. Together, we will explore, discover, and enjoy life through science. This is DepEd TV.